Welcome back. Like I said, I wanted to go over the spicy problem. It really isn't that much harder than the ones that we've been doing before. It just looks a little scarier. Same thing as before. We're trying to figure out where this parabola equals this parabola. So what we're going to do is we're going to write out our equation like this, right? Where is this parabola equal to this one, right? Where does that live on the graph? And once we get it here, we can solve this for x. I notice right away I've got 4x squareds on this side and 3x squareds on this side. So what I would do first is move these 3 on this side. These ones will cancel out, and 1 would take 4 minus 3x squared. We're left with just x squared, which is great because that's what we're kind of looking for in order to use Xbox, or the quadratic formula doesn't matter as much. But with Xbox, we might be able to find a nice, easy equation there. Okay, I still have 11x. And then over here, I still have 8x, and I have 7. Okay, I need to move everything over so I have that equals 0 that lets me solve these type of equations. So I'm going to minus 8x. Okay, and I'm actually going to kind of do another step in 1. I'm also going to take away 7 right now. Okay, those cancel, and I've got that equals 0 that I cared so much about. And again, I'm sorry, I'm blending 2 steps together here. I'm hoping you can follow along. Over here, we still have x squared. 11x minus the 8x is going to leave us with 3x. And if 3 minus 7 is negative 10. Okay? Because this is actually an Xboxable problem. Drawing my x, negative 10 on top, positive 3 on the bottom. What are all the numbers that multiply to 10? We've got 10 and 1, but the one that we're going to want is 5 and 2. Okay. In order to make all of our negatives work, we need to make the 2 negative, which means that our x values, when we flip everything around, are going to be 2 and negative. Okay. Still not done, right? I got to plug these numbers back into one of these equations. They're both kind of bigger ones. I might do the bottom one, I guess. So when we plug in 2 here, we get 2. 4 times 3 is 12. 2 times 15 plus 7. When I combine all those together, we get 2835. So one of the points where these cross is at 2, 35. Okay, and then the other number I have here is negative 5. So negative 5 squared is 25, and a negative times a negative is a positive. So 25 times 3 is 75. 8 times negative 5 is negative 40. And then we still have plus 10. And 75 minus 40 is 35, plus 7 is 42. Okay, so the other point where these cross is at negative 5, 42. Okay. If we go back and take a look at the graph, is one place at 2, 35. So 2, 35, somewhere up there where those 2 lines cross. And the other one's at negative 5, 42. So that one's a little bit higher, somewhere up there. Okay, so hopefully you're kind of tracking with how we can find the solutions for a system of equations, even when one or more than one of them are parabolas, right? This is all math stuff that you have the skills to figure out kind of going forward. Okay, great. The last slide on this slideshow is the homework for tonight. I would love it if you would take a peek at least a problem or 2 off of the homework. Just kind of get this routine down and get a little bit of practice with Xbox, because it has been a while since we've figured that out. All right, y'all. Have a great day, and I will check in with you guys again on Thursday. We are getting so close. We're so close to the end. Bye.